All right, let's take a look at coterminal angles. It tells us angles in standard position with the same terminal side are coterminal angles. So we're going to look for two coterminal angles for each given angle, one positive and one negative. So we have 65 degrees. So in order to find a coterminal angle, one positive and one negative, we're going to add one complete revolution to our circle. Okay, so if I take 65 and I add 360, I'm going to get 425 degrees. Now I'm going to take and I'm going to subtract one complete revolution from my 65 degree angle, and that's going to give me negative 295 degrees. So think about what we've got here. Here is my coordinate plane, my x and my y axis, and I've got a 65 degree angle. There's my initial side and my terminal side. Okay, so here is 65 degrees. Now think about what you've got when you've got 425 degrees. 425 degrees is going to be one complete revolution and then right back up to the 65 degree angle. Now think about when you have negative 295. That's starting still here at the initial side, but instead of going counterclockwise, that's going clockwise. So we'll start right here. This is negative 90, negative 180, negative 270, negative 295. So all three of these angles share the same terminal side. Okay, so looking at our next one, now this is already greater than 360. So we can do 540 minus 360, and that'll take away one complete revolution. And then we can take the 180 that we just got, and we can subtract 360 again to get the negative. Okay, so I'm subtracting 360 first to see what my angle is. It's a positive 180 degrees, one complete revolution, and then back to 180. And so then I can take that 180 and I can subtract 360 to get my negative. Okay, and so both of those would be coterminal angles. Now when you're dealing with radians instead of degrees, you'll do the same thing, but you'll do it with pi. So 13 pi over 18, so this is like your 65 degree angle, but it's not, but it's similar to. So what you'll do is you'll add one complete revolution, which is 2 pi. Okay, I'm going to go ahead and tell you the answer is 49 pi over 18. And then you'll take it and you'll subtract one complete revolution, and that's going to give you your negative angle. Now on number 13, we've got 14 knots. That's 1 and 5 knots. So we know that that's not a complete revolution. So since it's not a complete revolution, we'll do 14 knots minus 2 pi. Well, let's do plus first. Then we'll do 14 pi over 9 minus 2 pi. And we'll get 32 pi over 9 and negative 4 pi over 9, and these will be your two coterminal angles. Now when you do these, if you do your calculator again like we talked about before, you'll take your 13/18 and you'll add 2. You will not put the pi values in there, and you'll get your 49/18. You'll just put the pi in yourself. If you do 13/18 minus 2, you'll get negative 23/18. You'll just put the pi in there. Don't put the pi into the problem. Okay, if you do 14/9 plus 2, there's your 32 knots, and 14 knots minus 2. That's your negative 4 knots. You yourself have to put the pi value in there. And that's how you find coterminal angles. Now to find reference angles, it's very important that you read this definition. For an angle theta in standard form, the reference angle is the positive acute angle formed by the terminal side and the x-axis. Sketch and find the reference angle for each angle. So 225 degrees, here is my initial side. So we know that this is 0, 90, 180, 270. So 225 degrees is going to be in the third quadrant. Okay, we're going to go counterclockwise. So this is 225 degrees. Now to find the reference angle, it's the positive acute angle formed by the terminal side and the x-axis. So here's the terminal side and the x-axis. So this is the angle measure that I'm looking for. To find this, what I'm going to do, since this is 180, I'm going to do 225 degrees minus 180 degrees, and that's going to give me 45 degrees for this angle measure right here. And that's my reference angle. Now for negative 310 degrees, here is my initial side. Now remember, we're going clockwise for a negative. So negative 90, negative 180, negative 270, and negative 360. Okay, so starting right here, negative 90, negative 180, negative 270, so negative 310 is going to be located right here. Make sure you go clockwise, and you'll have negative 310 degrees. Okay, so we want our reference angle to be the positive acute angle formed by the terminal side and the x-axis. So we're wanting this angle located right here, okay? So if this is negative 310 degrees, only thing that you have to do is change it to its positive angle by adding 360 degrees. And that tells me that this is a 50-degree angle. Now, 2 pi over 3, that's the same thing as 120 degrees. Okay, so here is my initial side, and here is my terminal side. So make sure that you go counterclockwise, and this is 2 pi over 3, which is also 120 degrees. So we want to know the positive acute angle formed with the x-axis. So that's going to be this angle right here. Okay, so I know this is 0, this is pi over 2, and this is pi. So I'll take pi, which is this whole amount, and I'll subtract the 2 pi over 3, and I'll be left with pi over 3. And that is my reference angle. If you use your calculator on this one, you need to be very careful. Once again, we're used to being careful by now, I hope. And if you have pi, remember that's 1 minus 2 pi over 3, that's 2/3. And that'll give you your 1/3, which is pi over 3, okay? So be smart about using your calculator. Now let's go ahead and look at that bottom part to find our trig functions in the coordinate plane. So let theta be an angle in standard form, and the point xy is a point on the terminal side of theta, and the distance from the point to the origin, r, can be found using the formula x squared plus y squared equals r squared, okay? That's our Pythagorean theorem with an r instead of a c, and x and y instead of a and b. Because if you'll look at the diagram, you can see that it forms a right triangle with x for the x-axis, y for the y-axis, and this r, our radius, is our hypotenuse. So to find a sine value, okay, for our angle theta, remember sine is opposite over hypotenuse. So that means we'll have y over r. Cosine is adjacent over hypotenuse, so that'll be x over r. Tangent is opposite over adjacent, so that'll be y over x. Cosecant is the reciprocal of sine, so it'll be r over y. Secant is the reciprocal of cosine, so that'll be r over x. Cotangent is the reciprocal of tangent, so that'll be x over y. So to solve this problem, we have our point 5 and negative 2. So here is my initial side, and then if I plot 5, 1, 2, 3, 4, 5, and negative 2, okay, so this is what my angle looks like. And we want to find the exact trig functions. So what we're going to do, we have 5 and negative 2. We're going to do x squared, which we know is 5, plus y squared, which is negative 2 squared, is equal to our radius squared, which is unknown. So 25 plus 4 equals r squared. Take the square root, and the radius is the square root of 29. So we've got x is 5, y is negative 2, and r is the square root of 29. So to find sine, we'll put y over r. And then, of course, we have to get the radical out of the denominator. So rationalize, and you'll get negative 2 square roots of 29 over 29. The cosine is x over r, so that'll be 5 over the square root of 29. Again, multiply by the square root of 29 over the square root of 29. Tangent is y over x. Nothing else to do there. Now cosecant is going to be r, which is the square root of 29, over y, which is negative 2. Don't leave the negative in the denominator. Kind of put it on the side of the fraction bar, and you'll have the negative square root of 29 over 2. Secant is going to be r over x. And then cotangent is going to be x over y. And then again, we're going to put that negative kind of to the side.